Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 6, Lesson 4 on transformations of square root functions. Oh, what? Sorry, that's supposed to be cube root functions. I forgot to change it. I just copied and pasted the thing for the other thing because it's the same. The transformations are the same, except just that in the equation, remember, there's a cube root, not a square root. So we still have A, H, and K. So this video wouldn't make sense if you didn't watch Lesson 3. So just saying. So I already filled this in because I didn't need to write it again because it's the same. Remember, we have vertical stretches, compressions, reflections. You can move left, right, up, down. But let's look at what the reflections would look like. So a reflection, here's what it normally looks like. About like that. So really it just looks like the square root function if it also had a part that was turned upside down on the other side. That's kind of what it looks like. So if we had a reflection across the x-axis, then it would kind of just look like it was reversed like this. And if you had a reflection across the y-axis, it would do about the same thing. So that's just kind of how it is. Now if you have a vertical stretch and compression, when you have a stretch, it will kind of look like, instead of this, it will look like this, like crazy. And instead of this, for the compression, it would look like this, like smaller. So that's what that means. Because the words stretch and compression indicate getting larger or smaller anyways. So now that we know those transformations, we can graph. So we graph with the same techniques, we just change we look at what transformations there are, and then we change the points based on it. So we have a vertical compression this time of 1/2. So I'll just say VC of 1/2. We have plus 4, so that means left 4. We have minus 3, so that means down 3. Okay? Now, since we have that, let's see what we would have to do to these points. Okay, so if we have a vertical compression of 1/2, so we'll know what that looks like, E. That means, I'll just do this. That means we have to do y divided by 2. Or really, 1/2 times y. Same thing. And we have, since we had left 4, that means we need to have x minus 4. Remember, just because there was a plus 4 doesn't, in the original equation, doesn't mean you should add 4. It's because x, if you set x plus 4 equal to 0, x would equal negative 4, that's why. And up, and you have down 3, that's what the other thing was. So that means y minus 3. So we need to do all these. Once again, you have to do multiplication and division before addition and subtraction. So let's start out by dividing the y's by 2. Negative 2 over here divided by 2 is negative 1. Negative 1 divided by 2 is negative 1/2. 0 divided by 2 is 0. 1 divided by 2 is 1/2. And 2 divided by 2 is 1. Now we need to do x minus 4, so negative 8 minus 4 is negative 12. Negative 1 minus 4 is negative 5. 0 minus 4 is negative 4. 1 minus 4 is negative 3. And 8 minus 4 is 4. Now from that we need to subtract the y's by 3. So when you do that, you need to do we will change these. So I'm just going to write over here what these values are so I don't forget. Okay. Okay, so we have 1 minus 3, negative 1 minus 3, negative 4. Negative 1/2 minus 3 would be negative 5/2. -4 minus 3, or sorry, 0 minus 3 is -3. -3 minus 1/2, that would be, I'm trying to put it in fraction form, be -7/2. And 1 minus 3 is -2. So that kind of looks messy. I don't like that there's fractions in the coordinates, but that's just how it is. So we can't do the first one, 12, -4. But we can do -5, -5/2. So -5/2, that really means 2.5. So that would be right here. That's 1 point. Okay, let's look. We have -4, -3. -4, -3. So 3 of the points that you graph you'll find are really close. That's just how it is. Okay, so then we have -3, -7/2. 7/2, that's really 3.5. Okay, so those are those 3 points I was talking about. And really the middle one is what you would call kind of the vertex of it. And then you have 4, 2. 4, 2. 4, 2. I think we did something wrong here. I don't think that's right. Oh, that's supposed to be -2. I didn't draw the negative like good enough. It's hard to see. That makes more sense. That 4, -2. That would be right here. Well, still that kind of seems weird. I guess not really. So the function like that usually looks like that. So that's what we need to draw it like. There would be a point over here somewhere. So we have this, and we curve back up, and there we go. That's what this would look like. And drawing the original, let's see, like we did with the other one, how it changed. So we have 0, 0, and then these points. Remember, those are the same 3. We didn't have a reflection this time either, but and then we had 8. We have A2, and then we have -8, -2. And let's draw this. Okay, so how did it change? We can see that it, well, it's kind of odd. You almost would think that there was a reflection. I don't know. Did we have a reflection? No. Well, I don't know. Did we do something wrong? That seems weird that it would be like that. -5, -5. I guess not. That's how it is. Hopefully I didn't do something wrong, but that's transformations of cubic functions. So that'll be it for this video. Thanks for watching.